Hello, everyone, and welcome. My name is Francesco, and with today's topic 8, we're going to talk about how to figure out the construction requirements for your neighbor's building if your neighbor looks like this. Okay? I'm being a little silly, but I'm trying to make a point. What if that were your neighbor? Okay? So here's today's topic. We're going to cover subsection 3.2.3, spatial separation and exposure protection. So that's under Division B of the Ontario Building Code. So let me give you a TLDW, okay? So pretend this is your neighbor's house, it's on fire because your neighbor tend to spontaneously combust. What we're going to learn today is what the construction requirements are going to be for your neighbor's house to prevent those flames from jumping from their house onto the house I'm pointing to right now, yours, right? You don't want the flames to jump, or at least not too quickly, to your house. So we want to prevent the flames of jumping to your house from this house, which is your neighbor's house. Okay, so that's what we're going to learn about today. What are going to be the construction requirements for the outside of your neighbor's house? And I'm saying house, but I mean building. Your neighbor's building to prevent fire from jumping from their building to yours, or to affect you if you're walking nearby, or to affect, say, emergency services that are coming to save your neighbor. Okay? It turns out you actually already know what those factors are going to be that affect the construction requirements of your neighbor's building if they just happen to spontaneously catch on fire. Okay? And I'm going to show you what I mean. If you had a choice, if you had a say into what your neighbor's house would be, let's say you had one extreme choice and it were a bunker like this, okay? And the neat thing about this bunker, and why maybe it could make a great choice, is that it's low profile, right? So all the exterior walls are very low to the ground. It doesn't go too many stories high. The other thing too that's very helpful about a bunker like this is that it's far away from you, right? You see, there's no other buildings nearby close to your neighbor's house. Furthermore, there are few if no windows and few if no doors in this bunker, so that if fire does affect the walls, it really has a hard time getting through all these unprotected openings. Finally, the construction of this bunker is non-combustible, right? Concrete is one of those non-combustible materials. So that's option number one that you have to pick from your neighbor's house. Sounds like a great option for you to pick your neighbor's house or your neighbor's building. Consider option number 2 right here. Option number 2 is more of an open concept type building. It's high profile, so much taller than the bunker, and it's a lot closer to you, right? We're a lot closer to this building, so your neighbor's house is a lot closer. In addition to, you'll notice that it has no exterior walls. So there are no walls to contain the fire if it so happens, and the construction of it, what it's made out of, is actually combustible. You see that roof? That would catch fire very, very easily. Okay? So you have these two extremes that you can pick from, and I assume that if all you want to do was prevent fire from your neighbor's building to get to yours, you might go for this building. However, right, real life, nobody's going to build this as a typical house for people or a typical building for people. The solution is somewhere in between, okay? Between these two extremes is where the actual answer lies, and that's what the building code allows to do with this subsection. It allows you to estimate the construction requirements for the building you're analyzing. So let's call it your neighbor's building, and how much of the outside surface of your neighbor's building can be unprotected. So like windows, doors, or just straight openings like in this building. Okay, so that's what we're going to be doing today with this topic. First, profile dimensions. So how much the building goes above ground, how wide it is, okay? Because the bigger the building face, the more places for flames to get out. Next is going to be the distance. So how close the neighbor's building is to you if you're walking by, to your building if it's nearby, or to a street nearby to so that it doesn't affect those emergency services that are coming to save you, okay? Openings, so windows, doors, or straight up just holes in the building itself, right? Because you can have that. We saw that in the example that I had over here, like that Caribbean house. And finally, then combustibility. So what is the outside of the building made out of? Is it combustible construction, non-combustible construction? And what is the fire resistance rating? The kind of stuff we talked about in topic 7, okay? So let's talk about some of these specific topics and the 4 tables that we're going to be using for this topic. These 4 tables allow you to find the percentage of the face of the building that's allowed to be unprotected openings. Unprotected openings are like windows, doors. Literally, for the purpose of fire, there are holes in that specific face of the building that fire can get through, okay? The 4 tables we're going to be using are table 3.2.3.1b, C, D, and E. Each of these are basically the same table with some minor differences, okay? Obviously, because otherwise we just have one table. So here are the differences. B and C are for non-sprinklered buildings. Okay, that's what I mean by here. Whereas D and E, these 2 tables, are for sprinklered buildings. Furthermore, the difference between B and C tables is that B only is for major occupancies of A, C, D, and F3 major occupancies, whereas the C table is for E, F1, and F2 major occupancies. The difference between D and E tables, well, other than they're both sprinklered buildings, is that for D tables, it's for A major occupancies, B major occupancies, C, D, and F3 major occupancies, whereas the E table is for E, F2, F1, and F2 major occupancies. So let's just have a look at the tables so you can see that in the tables themselves, this information is in there, so you don't have to learn what I just wrote up here, okay? So here's table 3.2.3.1b. Do you see how in the title of that table it specifically says not sprinklered, okay? And then in the heading of the table, it identifies exactly what major occupancies are allowed to be used to use this table: A, C, D, and F3. Make sense? Okay, so let's look at the C table. And by C, I mean table 3.2.3.1c. It's the same thing. In the table itself, it will tell you this information. So notice how in the title, it tells you it's not sprinklered. And then in the header right here, it tells you what major occupancies, what building major occupancies the building must be so you can use this table. So E, F1, and F2. Okay? The next 2 tables, we're going to show them together because they're actually on the same page, like this. And in those 2 tables, you can see in the title, it actually says that they are for sprinklered buildings. And then in the header of those 2 tables, it tells you what major occupancies are covered by those 2 tables. So make sure you review that. Don't just pick any table to solve your problem, okay? Now, obviously, it would be fair if I gave you more information, right? I'm not just going to send you on your way. So we're actually going to dive in a little bit more into, I don't know, any of the tables. Let's start with the B table, table 3.2.3.1b. This is what it looks like, the table itself, okay? And for all intents and purposes, if we look at the very, very top row, there are 2 halves to this table. There is the left half, exposing building face, and there is the right half, area of unprotected openings for group A, C, D, F3 occupancies, okay? So let's look at the left half first, the exposing building face. This left half is actually broken down into 2 columns under it. The first one is maximum area in meters squared, and the second one is ratio, which is L over H or H over L. So what are those things? Let me show you, okay? So let's start with exposing building face. Exposing building face, if you ever find this in the building code, you'll notice it's written at an angle with an italicized font. That means it's a specific defined term. So if you go to Article 1.4.1.2 under Division A of the Ontario Building Code, you will find the definition for it. Read it, please. I'm going to tell you a Francesco-fied version of this definition. It's what I'm showing you here. The exposing building face is each face of the building, each side of the building that is facing a street or something, okay? So for this building here that I'm showing you, there are 4 exposing building faces. We'll call this one front, just to give it a name, okay? This would be the front of it, or if you knew the cardinal directions, you'd give those, like north, south, east, west, okay? And it looks like a 1, 2, 3, 4, 5 stories likely high building. The side of it here, there is no entrance, and it looks like a 5-story building, and all I see are windows and exit stairs, okay? The next exposing building face, it looks like there's some entrance or exit at the back, a lot fewer windows, and the back. This is, I guess we call it the back of the building. This is another exposing building face. And the final one, the side of the building, this one here, this exposing building face, 0 windows. Okay, maybe it's facing onto a parking lot. Okay, all right. Now, let's figure out how to identify those other dimensions we saw on the left-hand side of the table. So area, L, H, that sort of thing. The area for this topic is the product, the multiplication of H times L. The ratio is the division between L and H, or H and L. So what's H, what's L? Shall we find out? Let's do it. Let's start with H. H is the vertical distance that goes from ground level to the highest ceiling. H is not the building height, because as you know from topic 2 and other topics that we covered as well in the past, the building height, as defined in the Ontario Building Code, is the number of stories, okay? In this case, H represents the vertical dimension in meters from the average ground level for that specific building face all the way to the highest ceiling, okay? That's H. L is a lot more simple, and it's obvious. It's the side width, the horizontal dimension measured in meters from outside wall to outside wall. Okay, this one is more obvious. If you multiply the two, you get the area of this exposing building face. If you divide the two, you get the ratios of the exposed building face. So if we calculated H somehow to be 12.2 meters and L somehow to be 9.3 meters, the area would be the product of the two, 113.46 meters squared. The ratio, L over H and H over L, would be 0.6 for L over H and 1.31 for H over L. If we express the ratios the same way that those tables do, we add this division, like the colon, I think it's called, colon 1, colon 1. So you would actually read this ratio as 0.76 to 1 and 1.31 to 1. Okay, those two dots, you pronounce it 2, T-O. And it's just a ratio, right? You're dividing 0.76 by 1 and 1.31 by 1. That's how the building code shows it. So as soon as you calculate it, just add the 2, 1 right after them. Of the two, you always pick the largest ratio to find the value in the table. Don't forget, always the largest ratio of the two. So in this case, we would pick 1.31 as the correct ratio in this case. And then we would use these quantities, starting with area, to select the correct row in the table. Okay, so we use the area, 113.46 meters squared, to pick the correct row. So we go to the closest area without going over, but never under. So the closest area without going over, but never under, is a fancy way of saying round up to the nearest one, which is 150 meters squared in table 3.2.3.1b, the one that I'm showing right here. So we select that whole row, but you'll notice that that whole row has 3 rows inside of it. That's where the ratio comes into play. We have 1.31 to 1. So we go in the ratio column and we have to find the closest one to this. 1.31 is less than 3. Or another way of saying it is 1.31 to 1 is less than 3 to 1. So then we pick the less than 3 to 1 row. Okay, so you see how we're refining our row? Now, the other thing we have to do is find the correct column. And that's where the right-hand side of this table comes into play, this portion right here. This portion right here, the header for it, so the top row of numbers, is the limiting distance in meters. So that distance that we've been talking at the beginning of this video. In this table, it goes from 0 all the way to 50 meters. Okay? The content then of the table, once you go beneath the limiting distances, all of those other numbers are percentage areas of unprotected openings for buildings of A, C, D, and F3 major occupancies. That's what these numbers are. They're percentage areas. Not areas in meters squared, percentage areas. Now, in your course notes, I put a sketch like this that was created by the author of the course notes that sort of shows the 3 different types of limiting distance. But I'm going to mention those 3 types for you as well if you're not looking at the course notes right now. Limiting distance refers to that distance that your neighbor's building has to have to make everybody else around them be safe and feel safe. It's a defined term, so that means that the building code specifically defines what limiting distance is. So what I'm going to do is I'm going to take this kind of property and buildings on that property to try to illustrate the 3 different kinds of limiting distance. Okay? The first one is the distance from the exposing building face you're identifying all the way to the nearest property line that's facing that face. The second possible way to determine the limiting distance is the distance from the exposing building face you're analyzing to the center of the streets. This overrides the distance to the property line if there is a street beyond the property line. The third one is, for calculating limiting distance, is from the exposing building face to an imaginary line between 2 buildings if those 2 buildings are on the same site. Hi, I'm here. So I'm going to show you what I mean right there. Okay, let's say this building I'm pointing to right now is the building that we're analyzing, your neighbor's building for all intents and purposes. Okay, and there are 4 sides, right? 4 sides to that building. So I'm going to try to show you the 3 different ways that you could find the the limiting distance. First, to the property line. So you have to identify where the property line is for the building under consideration. I'm showing it as a red dashed dot line here. So the limiting distance would be from each of those exposing building faces to the property line around that building for each face. Okay, so there are 4 limiting distances because there are 4 exposing building faces. The second method to calculate limiting distances is to the center of a street. So even though this building might have a property line between itself and this street it's facing, as soon as there is a street, you automatically go for that specific building face to the middle of the street. The third one is in the case that you have more than 1 building on the same site, on the same property. So let's say that in red I'm showing the property lines and there are 2 buildings on that property line. Then the limiting distance for the building face between those 2 buildings, right, the faces that face each other, you draw an imaginary line between the 2 buildings, and it is going to be from that building face to this imaginary line. These are the 3 types of limiting distances that you can use. There are a couple of exceptions, and they are in these sentences right here. I'm not going to cover them in this video because they're going to be a little bit beyond the purposes of this introductory course, but you should go and review these so that you're aware of them, okay? So let's pretend that for our made-up building, we found that the limiting distance is 8.7 meters. You've been told or somehow you calculated. So what we're going to do is we're going to go back to this table, 3.2.3.1b. We've identified the actual row we have to use, and now we're going to use this limiting distance to find the column, right? So the two are going to intersect on a number in that table. 8.7. So we go to the limiting distance at the top, and 8.7 falls between 8 and 9. Which one do we use? 8 or 9 meters at the top? You always round down for these kinds of questions, okay? As long as you're not trying to find the limiting distance as the end result, you always round down the limiting distance. So we're going to use 8 meters for a limiting distance. And the two, the row and the column, intersect at 37. So this number that it intersects at, you can see it right there, it's 37. That's the percentage area of that specific face of the building that's allowed to be unprotected, whether it's windows, doors, or just holes in that face of the building. 37% of that face is allowed to be unprotected. Okay. Now, if you're also asked to determine the construction requirements of that face of that building, you would move on to table 3.2.3.7, which is just a few pages after these 4 tables we just identified. This table is very convenient because it contains the minimum construction requirements for each exposing building face that you're analyzing. And you'll see, starting with the middle column, it contains the construction requirements, including the fire resistance rating in the middle column, the type of construction required for the structure of that exposing building face, and the type of cladding required for the skin, because that's what the cladding is. It's the skin of the building for that exposing building face. So here are the steps to do a typical question where the end result is going to be the percentage of unprotected openings for each exposing building face. You want to start off first by identifying the correct table, whether it's 3.2.3.1b all the way to E, one of these 4 tables. And to do that, you have to use the major occupancy of the building and whether or not it is sprinklered. The second thing then you have to do is, once you've identified the proper table to use, depending on that table, you have to identify the geometric properties of each exposing building face of that building. So that can include the area, the H, the L, and the limiting distance for each of the faces of the building. Normally, in real life, you'd use the site plan to determine the limiting distance or other such drawings. For this course, you'll notice in the examples in your course notes or in the homework, the limiting distance will be very obvious, okay, in terms of calculating it. Then, from the correct table, you determine the percentage area that exposing building face can be unprotected, and then you convert that area to meters squared, because, right, in the table, it's all percentages, but what we use are meters squared. Finally, if needed, if you're told to do so, you also provide the construction requirements for each of those faces using table 3.2.3.7. So let's do an example, okay? A straight, obvious example. We have a building that looks like this, and we've identified an H